Okay, in this video we continue with chapter 1. Rounding numbers. The criteria we are going to use for rounding numbers is that anything greater than 0.5 is going to go to the next number. Anything below 0.5 goes to the previous integer, and anything that is at 0.5 is up to you how you want to do it. Okay, usually if it's 0.5, the conventional way is we go to the next integer as well. This is important to keep in mind because in our automated graded quizzes, that's how it's going to be set up. So keep that in mind, okay? Next slide. Here is when we are in the lab. We talk about this. You can read it on your own. How we are careful when we are handling the equipment. So we want to be aware of where we are plugging, usually power supply, so we don't get accidents. And the next slide is also about electrical safety. Electricity is dangerous. Not at the level we are going to be using it, because usually in the lab we deal with milliamp to microamp range. So it's really not that dangerous, but you want to be mindful that you have to be careful whenever you are handling. And remember, you are getting trained to work in a real lab with real dangers, so you have to be mindful of the electrical safety. Right here we are going to start doing some number crunching. So here are the basic rules that we have to follow when we are doing calculations with powers of tens. So addition and subtraction, they follow the same rules. We are going to, when we get the numbers to be added or subtracted, we want to put them in the same power of tens. We want to add or subtract the number independently from their power of 10. And then we are going to write down the result, whether that it is a subtraction or an addition. And what happens to the exponent is we just bring it down to the sum or to the subtraction results. For example, example number 4, right here it says add 2 times 10 to the power of 6 and 5 times 10 to the power of 7. So, and we want to express the result in scientific notation. That's important. You have to understand and learn how to follow instructions. They want scientific notation, so it's pretty common. That's how we usually operate, unless they ask for engineering notation. We are going to do examples of that, so let's finish this example. So the first rule, it says express in the same power of 10. We have power of 6 and power of 7. So we want to express in the same power. So in this case, they decided to bring it up to bring it down to power of 6. It doesn't matter if you bring it up to power of 7. They just choose to get it to power of 6. The result should be the same. So then just get the whole numbers. So when they bring it to the power of 6, the 5 became 50 because you are taking a 0 from 6 to 7. That is a 0, so that 0 is taken into consideration right here. So now you have 2 times 50, which is equals to 52. So you bring down that value and then take down the exponent, which is power of 10 to the power of 6. Here is where you have to be very careful, okay? We are asked to do it in scientific notation. So scientific notation, if you remember from previous lectures, we have a digit before the decimal point, and then as many digits as we want after the decimal point, and then that will be to the power of 7. For you to practice, you can add 4.1 times 10 to the power of 3 to 7.9 times to the power of 2. now let's do an example for the subtraction. The subtraction is the same model. We are going to take the exponents to the same power. So we have negative 12 and we have 11. Right here they are going to bring it down from 12 to 11 so that the 12 stays the same. So the 7.5 times 10 to the negative 11 stays the same. The one that is going to change is 2.5 to the power of negative 12. So now we are going to remove a 0. You see, when they are negative powers, it's a little tricky. You have to be careful. When they are positive powers, we add a 0. When it's negative powers, we reduce a 0. So 2.5, we take the decimal point to the left of it. That's how we reduce the 0. So it becomes 0.25 times 10 to the power of the negative 2. So right here, once we have them in the same power, we are going to subtract 7.5, 2.25 from 7.5. So we do basic arithmetic. So we get 7.25, and once we have that, it's already in scientific notation. Then we just bring down the exponent. So that's how we operate with exponents. Could you use a calculator and do it? Of course. Just make sure that if you use a calculator during the quiz, you have to know how to put it back into the exponent format that the quiz is asking at the time. Okay? So let's go to the multiplication. Multiplication is a little bit easier than subtraction and division because multiplication is only just have to add and multiply. So these are the steps. First, you have to multiply the numbers without their powers. Once you multiply the numbers without the powers, you add the exponents. So how? We have 5 to the power of 12 multiplied by 3 to the power of negative 6. So here we don't care that the exponents have different values. We only care to multiply 5 by 3, we get 15, and then what we do? We add the exponents. So 12 plus minus 16, minus 6, excuse me, it's, you are going to get a 6, but we are putting it in scientific notation, so the 15 times to the power of 6 is going to become 1.5 to the power of 7. Okay? Here we have it in engineering notation. Right here we have it in scientific notation. Please be very careful with the difference. And the difference is just the value of the exponent that it is raised to. Engineering again is multiple of 3, and it can have up to 3 digits before the decimal point. Scientific is 1 digit before the decimal point, and the exponent does not matter. It can be any number. For the division, just like for the multiplication, we are going to divide the individual values without their exponents. Once we get that result, we are going to subtract the exponent of the numerator. We are going to subtract the exponent of the denominator from the exponent of the numerator. So let's see how this works. So we have 5 divided by 2.5. So 5 to the power of 8 divided by 2.5 to the power of 3. So 5 divided by 2.5, we get a 2. Now 8, which is the exponent of the numerator, gets subtracted by 3, which is the exponent of the numerator. And that gives us 5. And that's your answer. And that concludes chapter 1 lecture.